All right, so let's begin today's lesson with end behavior of polynomial functions. This is what we ended with yesterday. Get it? End behavior ended with yesterday? Okay. I see what I did there? Okay. So, whenever I'm looking at stuff like this, I always like to reference something that's very familiar with me. And something that's really familiar to me, I should say, is a quadratic. I thought I changed the color. Why did it not change? All right, so a quadratic, right, is an even function. The end behavior of this graph is both going in the same direction, right? So an even function has the same end behavior. An odd function goes opposite ways. Odd, opposite. Make sense? Yes.
Well, I looked at it differently.
Okay, how'd you look at it?
I looked at it like in the quadrant of the graph, and I memorized which signs go in this quadrant.
Okay. I'm not a big one on memorization, but if that works for you, then that works for you. The way I look at it is if I'm trying to figure out whether I have a positive function, like for instance this one's positive, if I'm looking at this graph, isn't this the positive side? So a positive cube root would start like that and then go down. Make sense? And a negative one would start on the negative side. That's how I remember it. Negative starts on the negative side, positive starts on the positive side. If it's an odd degree, it means it's going to end on opposite directions. If it's an even degree, it's going to end in the same direction. Okay. So using that, I think we went through all of these, did we? We did. So is this odd or even? Even. Even. Is this odd or even? Odd. Is this odd or even? And odd or even? Is this positive or negative? Positive or negative? It's beginning at the negative side, right? Positive or negative? Positive or negative? Good. You guys got this. How is this one positive? They're both facing up, so it's a positive function. This one, it starts here on the right side. It's going up, so we know it's positive, right? This one, as I'm reading from left to right, it's going down, right? This one's negative. And this one, the end behavior, they're both negative. This one's a negative one. All right, so let's talk about what we're going to do today. So we are going to graph polynomial functions. So here's my polynomial function right here. And I suggest you talk about the behavior of the graph first, because then you know how to drive your graph. Okay? So let's talk about whether this is positive or negative. This is a negative polynomial function, correct? Okay, negative polynomial function. And then it's cubed, so that means what? What does cube mean? What does the cubic root mean? It's going to go in the same direction or opposite direction? Opposite direction. All right, am I going to start on the left and go like this, or am I going to start on the right and go like this? I'm going to start on the left. Why? Because it's negative. So this one's going to look like this. All right, before I even start graphing, just by looking at the behavior, I already know what it's going to look like. What else can I tell by looking at this equation? Oh, well, we can't really, the steepness is harder to do because there's so much going on here. Why do you know it touches the x-axis twice? We can't tell whether it touches the x-axis twice, but we can tell that it has, at most, 2 turning points. Can anybody explain to me how I would know that? Evan, what do you think?
Going down, up, and down again.
Okay, but just by looking at this. Yes. The exponent, exactly. What about the exponent? Okay, so the exponent's cubed, right? So it's to the 3rd degree. We can have at most 1 less than that. So I could have 3, or I'm sorry, since it's cubed, I can have 2 turning points or 1 turning point, but I can't have 3 or more. If you forget about that, just go back to what is familiar with you. This is x squared, right? So at most, how many turning points could I have? 1. Isn't there only 1 turning point? It does a u, right? Okay, so that's what I know before even graphing anything at all. Yes? The degree of the polynomial -1. All right, I guess we can also say this function is going to do what as x goes in the positive direction? It's going to be negative, right? As I'm going in the positive direction, it's going to go down, right? What would the function do as x is going negative? It's going to go positive. But you don't have to do that on your homework. I just thought I would tie that back in there again. Alrighty, so this actually should be a -5 right here. So if I were to substitute in -5 into my equation, I would get opposite of -5 cubed minus 4 times -5 squared equals 25. I'm going to do one more for you. -1. Sorry, I'm looking at the wrong side. -4. So if I were to substitute in -4, I would get -4 cubed minus 4 -4 squared, and I would get 0. I'm not going to ask you to do that for every single one. You can put it in a calculator. You don't have to do those calculations in your head. All right, I'm going to go along here and say -3, -2, -1, 0, 1. When I put in -3, I get -9. When I substitute in -2, I get -8. When I substitute in -1, I get -3. When I substitute in 0, I get 0. And when I substitute in 1, I get -5. Oh, that was something else we could have known by just looking at this. Is there a constant? Or what is the constant? 0. So I know it crosses the y-axis at 0. That doesn't help you very much, right? But, all right, so it's nice that you are given that we can start at -5, but if you aren't given a point to start with, that would be where I would start, 0, and I would work my way out and see what happens to my graph. All right, so when we're graphing just regular quadratics, I told you you needed 3 points to figure out the behavior of the graph, right? And then just graph it. But these, there's a lot going on with these, right? Can you just graph those with 3 points? No. So that's why I've got -5, -4, -3, -2. I want to see what's happening as I go along that x-axis. Remember I said that's what's driving us. We talked about what are the solutions of a graph. The solutions are when it hits that x, right? So a lot is happening. This is kind of like our reference point. What's happening as I walk along that x-axis, and that's what we're going to discover right now. All right, so if we put in -5, we get 25. I can't even graph that. 1, 2, 3, 4, 5, way up here somewhere. We're just going to use that as a reference. -4, 0. 1, 2, 3, 4. So I'm starting here, and my graph shoots down really fast. -3, -9. 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. Bless you. Negative 2, negative 8 would be here. What just happened there? We got a turning point, right? Negative 1, negative 3. 0, 0, we already have that one. And 1, negative 5. What just happened there? Another turning point. 1, 1, 2, 3, 4, 5. So my graph, let me try and do this as nicely as I can. Does it look like the behavior that we expected? It does, right? All right, let's talk about our zeros. Do we have zeros? We do. We have one here. And we also have one here. So my zeros are negative 1, 2, 3, 4, negative 4, and 0. And my relative maximum, why do you think we call it relative? Can we say it's absolutely our maximum point? It's a sketch, right? It's not, I mean, I didn't plug in and find my vertex point, right? So, again, I'm talking about the x-axis, and I'm talking about what happens as I go along it. So as I go along the x-axis, I have, as soon as I hit right about negative 3, I get a turning point, or a relative minimum. So I would say my relative minimum is at about negative 3. Keep going, keep going, keep going, and then we have another turning point here, so I have a relative maximum at about 0. Questions so far? Yes? Where's the negative 3 come? See this right here? Where does that happen on the x-axis? At negative 3. See it? And then this one happens at 0. And we're talking about the x-axis driving what's happening to this graph, right? It's almost like this is the control panel right here, right on the x-axis. Yes? At most, there are 2 turning points on this graph because it's a cubed function. Subtract 1, and that's at most the most you're going to have. So if this was to the 4th power, you're going to have either 3 turning points or less. Make sense? Okay, let's try another one, and then I'll give you your notes, and you can go ahead and copy this down. Okay, here's another one. Let's talk about what it's going to look like. It's positive. Perfect. What else do we know about it? There's 2 at most, right? So less than, I should say it the other way around, less than or equal to 2 turning points. What else do I know?
At 0, 6 is a point.
At 0, 6, there is a point. 2, 3, 4, 5, 6. Good. Because I have 6 as my constant, which is my y-intercept. Got it?
Yeah, y equals
Like y equals mx plus b, right? That b is the constant, right? What else do I know? Is it an even function or an odd function? Even? Cubed is even? It's an odd function, which means what? My end behavior is what? The same or opposite? Opposite. Which way am I going to start? On the right and go down, or on the left?
On the right.
On the right. So it's going to look something like that. Everybody got it? All right, let's go. So I've got negative 2. My next point would be negative 1, 0, 1, 2, 3, 4. I'm not even going to have to go to 4, and I'm going to show you why. 3, 6, 5. I did these ahead of time for you guys. 6. I figured, do I really need to teach you how to do that? No. Yes. Why do I not need 4? Because you can't even go to 15, and if this is the end behavior, it's probably going to be shooting up anyway, right? So we really don't need 4. Okay, let's talk about what we can tell without even graphing at this point. Negative 10 to 3. That means I'm at negative 10, and then I go up to 3. So what happened there? It's not a turning point, almost. I just crossed. There's a 0 here. In between negative 2 and negative 1. I'm at 3, I go to 6, I go back down to 5. 3, 6, 5. There's a turning point there. You don't have to do this. I just thought we'd talk about it. Okay? Then I'm at 6, and then I'm at 5, 6, then 5, then 6. Another turn. And then I go from 6 to 15. That means I'm probably just going to, that's the end of my going off into infinity at that point, right? All right, so I'm going to go ahead and graph this. Negative 1, 3, negative 1, forgot negative 2, negative 10. Negative 2, negative 10 is down here. Negative 1, 1, 2, 3 is there. 0, 6 we already have. 1, 5, 2, 6, and then 3, 15 is off there somewhere. So I'm going to try and attempt this one. Not too bad. All right, where are my zeros? I only have 1 0, and it's right in between. Between what two consecutive integers? Negative 1 and negative 2. We can't really talk about what it is exactly, right, because this is a sketch. But I can say that it's between negative 1 and negative 2. I say consecutive integers because consecutive means in order. Integers means numbers on the number line. Okay, relative max. So let's talk about our maximum. I'm going along the graph and I hit a curve at 0, so at about 0. And then I hit another one at about positive 1. The book says 3/2. I would say 1. Okay? Can you really tell? I mean, it looks symmetrical right there. And that's it. Questions? You guys ready for this?
Yeah.
All right, so I'm going to go back to the first one and let you guys copy that and pass out your homework. Okay, so why don't you guys go ahead and try this one on your own now, and then, is it frozen? Sorry. Okay, so go ahead and try this one on your own, and then I'll go over the answers with you. For those of you that are done, then just keep moving on. Go to your homework. The rest of these are your homework. Okay, so this is what number, was it 13? 13 should look like. Well, it just goes, right? Do I need it to go all the way? The arrows tell me that it continues to go this way. This is the real important stuff right here. Right? Right? That's happening right here. Questions? Yes? No. You have to put in between negative 1 and 0 because it's not actually on 0 or 1. And at 1 and between 2 and 3. Poor Matt. Okay, let's pause. All right, so let's go through our closing thought here. So what did you learn today?
Learn how to graph polynomial.
Excellent. How can you tell when you have a sign change? It's crossing over the x, right? That creates a sign change. When is it possible to locate a maximum or a minimum? when it's turning, right? And what about this one? Negative x to the fourth plus 2x cubed minus 4 has at most how many turning points? 3 points. Good job, guys. All right, let's go over homework.